Hello, third grade. Today we are going to be learning about gravity. We are going to find the section of our book that we're going to read on page 86 of our book. So let's think about what we know about gravity already. What would happen if I held a ball out in the air and I let go of it? Would it go up, left, right, or would it fall to the ground? You're right if you said that it would fall to the ground. A force pulls it downward, and that force is called gravity. Almost any object that we let go of will fall to the ground. So let's look at our book now. Our heading says gravity. Let's look at the photos before we begin to read. We see a football player kicking a football. So, our passage says, what is this football player doing? He is kicking the ball. The ball goes high in the air, but then what happens? The ball falls back to the ground. Why? Gravity pulls it down. Earth's gravity is a force that pulls things to the center of Earth. Gravity is one of the many different forces that does not have to touch objects to have an effect on their motion. Gravity pulls on objects without touching them. So let's look at our caption really quickly. It says, gravity will pull this ball back to the ground after the player kicks it into the air. So if we think back, we remember that there are forces that have to touch in order for force to work on them, like friction. But gravity is a force that doesn't need to touch to work. So gravity is a force that pulls objects toward the center of Earth. Objects don't reach the center of Earth because they are stopped by the ground. So when the football player kicks the ball, what force causes the football to move up through the air? The force that causes the ball to move up is the force of the foot kicking it, or a pushing force. But the foot needs to touch the ball in order to push it. What force will cause the ball to fall to the ground after it's kicked? That must be gravity. Is gravity a pushing force or a pulling force? Well, if it's moving things towards the ground, it must be pulling them to the ground. So gravity is a pulling force. So unlike the force of the kick, gravity does not touch or contact the ball. It pulls without touching. Think about a time when you've held your arms above your head for a long time. You're using force to hold your arms up. Your muscles are pulling them up. What other force affects your arms when you have them up in the air? That must be gravity trying to pull them down. So, why does gravity make your arms feel tired? Well, gravity wants to pull your arms toward the center of the Earth. It doesn't want them to stay up in the air. Your muscles have to fight against gravity to hold them up. That's why your arms get tired. But what else does gravity pull towards the center of the Earth? It pulls everything to the center of the Earth. So let's look at page 88 of our textbook. Let's look at the little girl that's jumping rope. She's jumped off the ground. So what force did she use to get off of the ground? Well, she used her feet to push away from the ground, so she used a pushing force. What do you think is going to happen next, now that she's off the ground? Gravity must be about to pull her back down. That's what happens every time I jump up in the air. Gravity pulls everything toward the center of the Earth, even when it's not on the ground. So let's read page 88 now. Our passage says, gravity pulls on everything on Earth. Try this simple test. Hold your arms over your head. What happens after a few minutes? Your arms start to feel tired. Why did your arms get tired? Gravity was pulling down on them. Gravity made your arms feel tired and heavy. It feels good to let your arms down and relax. Our caption says, gravity pulls everything toward the center of the Earth, even you. Now let's look quickly at page 89 and read our passage. It says, has a doctor ever measured your weight? Weight depends on gravity. It also depends on the mass of objects. The pull of gravity is stronger on objects with more mass. This means objects with more mass weigh more. A stack of books feels heavier than one book. The pull of gravity is greater on the stack of books. The weight of the books is the measure of the pull of gravity's earth on the books. Let's look at our little photo insert and read its caption. It says, weight measures the pull of gravity. So, weight is a measure of how much Earth's gravity is pulling on something. So, a big dictionary is heavier than a little notebook, even though they're both made out of similar material, paper. But one is heavier than the other. Why does gravity make the pull more on the dictionary and make it heavier than the notebook? Well, that must be because there's more paper in the dictionary, which means that it has more matter, which means that it has more mass. And gravity pulls heavier on things with heavier mass. So what two things does an object's weight depend on? It must depend on the mass and the gravity. So how does an object's mass affect its weight? Well, if it has more mass, that means it has a stronger pull of gravity, and that makes it weigh more. So every object's weight is a measure of the pull of gravity on it. All right, the last thing that we're going to do today is we're going to look at the questions that are at the bottom of page 89. So the first question says, what is gravity? So let's look back at our book and see if we can find the answer. Our second question says, what does weight measure? Let's see if we can find that answer too. And our last question says, apply. One grocery bag is filled with jars of peanut butter and jelly. Another grocery bag is filled with bread. Why does the second grocery bag weigh less than the first one? So you'll have to think about how weight works to answer this question. All right, third grade, you did an excellent job today with reading along with me. We're going to continue to talk about weight, mass, gravity as we read more about this chapter. But remember that gravity affects everything we do every day, so it's a very important thing. Excellent job.